Okay, so I want to show you what different functional groups look like. And so I've created sort of a page here or two to go through that. So let's do a really quick review of what the different functional groups are. And yes, you need to commit this to memory, but hopefully I can give you some pointers here. Okay, let's start with alkanes. Alkanes are simply single bonded carbons. So a long chain of whatever you may have there is just an alkane. So this is sort of the standard, back and forth type of structure. And that also gives you a condensed formula that's the CH3, CH2, CH2, CH3. So if you spot something that's different than that, that's a clue that something else is going on. And that might be a good way to think of it. Next, we have alkenes. So alkenes have a double bond somewhere in their structure. And really, if you just have a double bond somewhere in the structure, that particular group is still an alkene. You can have multiple functional groups in the same structure is what I mean there. And you can spot that on the end, it would be CH2CH in the condensed structure. That's going to be different if you've got something in a ring or in the middle of that chain, but I'll let you figure that one out. And you see this simply by having that double bond right there within the structure itself. And next we have an alkyne. An alkyne, I always say it does all kinds of stuff, So it's got a triple bond right there between two carbons. You can have a triple bond between carbons. You can't have 4 bonds between 2 carbons. So this massively affects the amount of hydrogen that you have there. See how few hydrogen those 2 carbons have? That's what I mean. Okay, and right here we have a triple bond. Now, the thing that you have to keep in mind, and one thing that is different with these carbons, this guy right here is a carbon. This guy right here is a carbon. And then this guy right here is a carbon. Okay, now, if you don't believe me that thing should be straight, I want you to get out a model kit and look at what happens to this carbon right here, okay? Because you have a triple bond going in one direction, that carbon is really only attached to 2 atoms. So it's attached to the carbon that's on the left side, it's attached to the carbon that's on the right side. See this right here? That carbon is only attached to 2 things. And the way for it to get furthest apart from one another is a line. And so when we draw these, you have to be super careful how you draw them, because that little dot right there is still a carbon, and you should keep that as a straight line. Okay, so practice drawing alkynes because they are more complex. Next, we have aromatic compounds. So aromatic compounds are going to be really just a phenyl group, or another way if you've heard of that before. We have a ring with alternating single and double bonds. There are different types of aromatic rings. They're all rings, but we're not going to go into that too much. I just want you to be able to recognize what these things look like, and you can't do that in a condensed structure. This is how we could write that structure as single and double bonds that are alternating. Or the shorthand version is this guy right here. So we'll talk about that in class as to why that's even there. But that's what I tend to write, honestly, a lot of times. Next, we have an alcohol. Alcohols have an OH. They could be at the end of a chain. They can be in the middle of a chain. It doesn't matter. If you have an oxygen that's connected to both a carbon and a hydrogen, that is an alcohol. Here again, we have OH and OH, okay? Now, if you add another oxygen to the carbon that's attached to the OH, so see, now we have an O that's going up. We call that a carboxylic acid. Not to be confused with an ester that we're going to look at the next page. Okay, there's multiple ways to represent this in condensed formula. It could be COOH or CO2H, it just depends. And this is how we would represent that in our line bond Kekuli structure. Next, we have an aldehyde and ketone. These kind of like go hand in hand. They're kind of easy. Once you get one, you get the other one. An aldehyde has a C double bond O at the end of a chain. So this carbon right here is attached to an H, in addition to being attached to that oxygen. And so it's just COH at the end. So you do have to have that O there. This can be confused when you write it this way really easily with an alcohol. The difference here is that this COH is just COH. Notice up here at the end of an alcohol, you would have CH2OH. So it's one, it's like one little bond difference there. And that you have that carbon that's double bonded to the oxygen here, so you don't have any room for hydrogen on him other than that one hydrogen there on the end. You can represent this also two different ways in a Kekuli structure, and sorry I didn't put my lone pair of electrons on those oxygens, so I probably should have done that. But you could just write like this way, like, yeah, hey, that oxygen's over there. Or sometimes you see that this hydrogen is drawn out. Either of those is correct, okay? Next, we have a C double O bond in the middle of a chain. It's very much like this aldehyde. It's called a ketone. And that's it. You just have the C double O bond in the middle of the chain instead of on the outside, okay? And so this is how we get that right there. And that's a C double O bond right there. Next, we have what's known as a thiol. And thiols are like alcohols. It's just you replace that O with an S. That's it right there. Okay? Okay, just a few more here. Next, we have ethers. Now, ethers are like alcohols, except for the fact that the oxygen that's involved is connected to two different carbons. And it could have a multiple, it doesn't matter what's over there. But it's not just, it's not an O with an H on it. It's an O in the middle of a chain. And so that's what makes him different. Next, we have esters. These are like carboxylic acids, except for the fact that they are in the middle of a chain as well. So this is a COO in the middle of a chain. So we've got COO right there and CO2 right there, okay? So there we go, COO. Notice that this is not a hydrogen, right? That is some form of carbon on the other side. Okay, two more. Next, we have amines. Amines, it doesn't matter where they are in the chain. They're still called an amine. And this nitrogen right here can be connected to hydrogen. It can be connected to carbons. It doesn't really matter. If you have a nitrogen, it's a amine. And so we could write that as an H2. In this case, I gave you an example with an H2, but they could have different types of connections, okay? And next, we can have amides. Here's the difference between an amine and an amide. There's the amine type of functional group, but the carbon that this nitrogen is attached to also has a C double O bond right there. Now, this is a very special bond. This is what puts together your proteins. We're going to talk about that soon. So this you definitely need to understand is different than what you have as an amine up here, okay? Or at least be able to visually recognize it. And we write that as CO in H2, and this is sort of what it looks like. So we're going to talk about this a lot later in the semester. I hope that helps with functional groups, and I will see you soon.